All right, one more quick video for Chapter 8, Section 5. We're going to be looking at example 8-29 on page 468. And this one is another example of not only just finding the p-value, but here using the p-value method in order to complete our hypothesis test. The theme of this problem is car inspection times. It says a researcher knows from past studies that the standard deviation of the time it takes to inspect a car is 16.8 minutes. A random sample of 24 cars is selected and inspected. The standard deviation is 12.5 minutes. At alpha equals 0.05, can it be concluded that the standard deviation has changed? Use the p-value method and assume that the variable is normally distributed. All right. So, using the p-value method, we still start out the same way. In step one, we will state the hypotheses. And so here, 16.8, that is the hypothesized value for sigma, for our standard deviation, because that was the value that we found from the previous study. And we're just trying to see if it changed. So our alternative hypothesis, H subscript 1, the research hypothesis, is going to be simply that it's not equal to 16.8, that it just changed. Right. Next. For step 2 in the p-value method, we actually go ahead and calculate the test statistic. So here we're going to be taking n minus 1 times s squared times, divided by 16.8, whole thing squared. I think I said S, and I wrote in 12.5, and that is actually perfect, because that's what we want to do. So then after we complete this calculation, we get 12.733. And so then the next thing to do is to calculate the p-value. Step 3, we'll go ahead and do that. So here is our distribution curve. The degrees of freedom that we're going to remind ourselves that we're using is 23. And we have this value, I don't know, I'll put it right here, 12.733. Now we have to look up the p-value for this chi-squared. And so the values that we find using table G for the chi-squared distribution on, well, in row 23, we have this value here is 11.689. And then we have another value on this side. It is 13.091. And our chi-squared values in between. So here, for this chi-squared value, we have a right side area of 0.025. I'm sorry, excuse me, a left area of, I'm saying this all kinds of wrong. So we have a right area. The table only gives us right areas, and the right side area is 97.5%. So that means this shaded in area on this is 0.025. The 13.091 value is in the column that says 0.95. And so that means that this shaded in area here is 0.05. Okay. So if we were looking at the area that I'm shading right here, that would be somewhere in between 2.5% and 5%. So there's one extra little thing that we have to do for the p-value in the case where we are using a two-tailed hypothesis test. We have to double the area that appears underneath one single tail. Okay. So it's basically kind of like this area is so much. I don't know how much it is exactly. It's somewhere between 2.5% and 5%. And so basically the complete p-value is this shaded in area on the left side plus this equal amount of shaded in area over here on the right side. Okay, we don't have to draw that picture. We don't have to shade those in. We just have to remember on the left, we have this area 0.025 and 0.05. Okay, for our p-value, we have to do each one of these times 2, and times 2. So this is going to be 0.05, and this will be 0.10. And our p-value is somewhere in between. Okay. So what does that mean for us? Our p-value is in between 5 and 10%. And so that means that it is bigger than 5%. And so we will fail to reject H subscript 0. So we'll say, don't reject H subscript 0. So that means that we didn't uncover enough evidence to show or illustrate whatever we said as our research hypothesis. And so what that means in this particular case is there is not enough evidence to show whatever they said for our research hypothesis. So that would be saying that the standard deviation is different than 16.8. So it was 16.8 in the previous study. We haven't unearthed any evidence that it has made any significant changes. And so that's all we're going to say. No evidence that it changed. That's it.